Hi and welcome to Calculus 30 with Miss Verity. Today we're going to be looking at 4.9, combining differential rules. So determine the derivative of the following, simplify by factoring completely. So what we're going to do is we're basically going to take all the other rules we've ever learned in the past couple weeks and we're going to use them. So things we know, what do we know? Oh my gosh, the power rule, constant rule. So power rule is just where you have like an x squared minus 4x plus 3, and the derivative is 2x minus 4. That's what the power rule is. Our constant rule is the idea of the derivative of 3 is 0. We know the product rule, which is where we have two things that we're multiplying, quotient rule where we have things where we're dividing, and the chain rule where there's pieces within pieces. So our first one here, A, we are multiplying two terms, so that is a product rule. But again, I would always think of, do you like the look? I don't like radicals sitting there, so I'm going to change h of x to be x cubed times 3x plus 1 to the 1/2. And so now looking at that, we actually have a product rule and a chain rule. And so we're basically going to use the product rule as our prime rule. So when we take our derivative, we're going to take the derivative of the first term. So derivative of x cubed is 3x squared times our second term, 3x plus 1 to the 1/2. Plus, we're going to take the derivative of our second one. So when we take the derivative of that, that's going to be a chain rule. So 1/2 3x plus 1 to the negative 1/2, because I'm going 1/2 subtract 1, which is the same as 1/2 subtract 2 over 2, times the inside derivative of the inside, so 3x, times our first, because the first comes from, that's part of our product rule. Whew. And so now what we're going to do is we're going to simplify and factor out as much as we can. The first thing I like to do is I like to simplify both of my sides, so I don't have, I look at the right hand side and there's tons of different terms. Let's try and narrow it down. So 3x squared times 3x plus 1 to the 1/2, plus I'm going to end up with 3 over 2 x cubed times 3x plus 1 to the negative 1/2. Well, now notice I've got 3x plus 1s on both of my terms. I'm going to take out my common factors. So this is like in our first unit where we take out the largest negative power. Well, in both terms, I also want to take out all of my fractions. So I'm going to take out 3 over 2 x squared, because that's my largest sort of regular x term. I'm also going to take out, I guess I could put that in brackets or not, the largest negative. So 3x plus 1 to the power of negative 1/2. That's my largest negative power. So within that, now if I look at my first term, technically what I've done is I've divided each of my terms by whatever those common factors are. So if I took out 3, it's that 1/2. So when you divide by 1/2, you're really multiplying by 2. The x squared came out, that's fine. So then again, with those negative powers as a common factor, when we think of that, what I did is technically, again, we're dividing, so when we divide exponents, I have 1/2 subtract negative 1/2. Well, that gives me 2 over 2, which is 1. That means that this 3x plus 1 is now technically to the power of 1. And in my second term, I'm just left with an x. And so now within that, I'm going to simplify that expression that I have, the stuff that's in red. So 3 over 2 x squared, I've got my common factor of 3x plus 1 to the negative 1/2. And if I distribute the 2, I've now got inside my brackets 6x plus 2 plus x, which is going to leave me with 3 over 2 x squared, 3x plus 1 to the negative 1/2, and 7x plus 2. That is what my f prime of x, or I guess h prime of x, because we started with h, that is what it is equal to. So now if I look at my second one, I'm going to do this one in blue just because, different colors. Again, personally, I'm going to say I don't like the look, so I'm going to change that. So g of x is equal to negative 2x squared all over 4x minus 3 to the 1/2. So looking at that, that looks like a quotient rule. And while that's delightful, personally, not a fan whatsoever of the quotient rule. I prefer a chain rule or a product rule, because then I don't have like, ooh, ultimate stacking. In this case, I'm going to have to cancel out a bunch of terms to get common factors, and ugh, not fun. So what I would rather do is I would rather change this to be negative 2x squared times 4x minus 3 to the power of negative 1/2. Remember, anything that's in the denominator is really just a negative power in the numerator. And so now I have a product rule, which personally I like much better. So when we take the derivative, so derivative of the first, negative 4x, times our second term, 4x minus 3 to the power of negative 1/2, plus the derivative of the second, so negative 1/2, I'm going to put that in brackets just so I don't lose my negatives, times the inside stuff, where I'm going to decrease my power by 1. So I have negative 1/2, and I'm going to subtract that by 1. So I'm going to have negative 3 over 2 as my power, times the derivative of the inside stuff, because I'm doing a chain rule, and because we're also doing a product rule, times the derivative of the first, or sorry, times the first, not the derivative, just the regular. Okay, and so now we're going to simplify. So I'm going to keep my negative 4x here, 4x minus 3 to the power of negative 1/2. Well, I'm going to look at my other side. I've got negative 1/2 times 4, which is going to give me negative 2, times another negative 2. So that's going to be positive 4x squared. What I did is I multiplied those three terms together. And I'm left with 4x minus 3 to the power of negative 3 over 2. And so now at this point, we are going to take out some common factors. So a common factor is going to be, well, one of them is going to be negative 4. I'm going to make that be a common factor. I'm also going to take out 1x. And now we're going to take out the largest negative. So my largest negative power that I'm taking out is 4x minus 3 to the power of negative 3 over 2. Okay, so what does that leave us with? Well, our first one had a power of negative 1/2. So again, if I've got negative 1/2 and I'm subtracting negative 3 over 2, that means, you know, when you subtract negatives, you add the opposite. So that's 2 over 2, which is 1. So this is now 4x minus 3, technically to the power of 1, but the power of 1 really doesn't do anything, minus, not plus, because remember we took out a negative, and we're left with just an x. And so now if we continue simplifying, my g prime of x is going to be negative 4x minus 3 to the negative 3 over 2. And what do I have here? 3x minus 3. Ooh, this is actually interesting. If we look at that last term, we actually have a common factor of 3 in that last term. We also want to take that common factor out. So if I take out the 3, I now have negative 12x, 4x minus 3 to the power of negative 3 over 2, and I'm left with x minus 1. I mean, also hopefully I didn't mess up anywhere in there. There's a very good chance. But with that in mind, you also want to be very careful that you are showing all of your steps. It is very easy to lose negatives. I'm also going to agree with that, because when I did this example on paper, may have lost, you know, a negative. And so showing all of your steps, being very methodical, and yes, doing some steps in your head to be more efficient. Like, notice I did all my fraction work in my margins. You don't have to do that if you, because especially as you get really good at taking out the negatives, you get really good at being able to do those fractions in your head. All right, this next one. So there's a bunch of information that we're given. So we're asked to determine f prime of 1 for each of the following. Okay, so our first one, we want to think, what type of derivative is that? Or like, what type of derivative rule? Well, that's just our power rule. So our capital F prime of x is just going to be 2 times f prime of x plus 3 times g prime of x. And our x is going to be at 1. So f prime of 1 is 0. So 2 times 0 plus 3 times our g prime of 1 is, if I can find it somewhere up there, there we go, -2. So our f prime of 1 is going to be -6. Our next one, well, we're multiplying, so that's going to be a product rule. So our f prime of 1 is going to be h prime of 1 times g of 1 plus g prime of 1 times h of 1. Well, h prime of 1, h prime of 1 is 4. G of 1 is 7. Plus g prime of 1, so that's -2, times h of 1. H of 1 is 2. So we've got 28 minus 4, that's equal to 24. All right, our next one, we've got a chain rule plus a power rule. Sorry, this should be 3f of x is what that should be. All right, so our chain rule, well, that's our f prime of 1 is going to be h prime of g of 1 times g prime of 1. So that's our chain rule plus 3f prime of 1. Okay, so we're going to slowly add pieces. Well, g of 1 is 7. So h prime of 7 times our g prime of 1 is -2. So that's this piece. Plus 3 times we need an f prime of 1. F prime of 1 is 0. F prime of 1 is 0. Okay, so now we still have an h prime of 7. H prime of 7 is 1. 1 times -2 plus 0. So that's equal to -2. And then last but not least, we've got g of h of f of x. So what does that look like? Well, let's start. We're going to have g prime of our h of f of x. So that's sort of the derivative of this piece times the derivative of our inside stuff. Well, the derivative of our inside stuff is another chain rule. So this is like a chain rule in a chain rule. So within there, we're going to have our h prime of f of x times our f prime of x. I think I've got all my brackets. All right, so now let's start putting stuff in. And I guess I should label it, or capital F prime. Okay, g prime of h of f of, we're doing this at 1, so f of 1 is -8. F of 1 is -8. Times, we've now got our h prime of f of 1, also -8, times our f prime of 1. F prime of 1 is 0. Ooh, this is real nice. Okay, so, I know that there's times a 0, and this is all multiplied by 0 at the end of the day, but what I want to do is keep going just in case, like, it wasn't actually a 0. That's, not good on my part. So if I was to keep going, I would find h of -8. Well, h of -8 is -1. So g prime of -1 times h prime of negative 8, h prime of negative 8. Do I have it? Oh no. Okay. I have g prime of 8. Why do I not have an h prime of negative 8? Okay, well, rip, I guess. Well, maybe I did know it. We know that this goes to 0 because h of negative 8 times 0 is going to be 0. Anything times 0 is going to be 0. Therefore, our answer is 0. Classic. Should have had an h prime of negative 8. You know, next time. Next time.